Hello, Algebra 2 students, and welcome back to Lesson 2-2. We're going to pick up from where we left off with example 4. And this example you'll see is quite challenging, so follow along. If you need to pause the video, pause it, back it up, watch it again, okay? Because you'll see this is going to end up being quite a bit of work. We're going to use solving systems to come up with the equation of a parabola given 3 points. So this is different from the problems we were doing earlier. Notice none of these are just 3 points that the parabola passes through. None of these are the vertex, none of these are a y-intercept. So what we're going to do is set up a system by using our standard form, ax squared plus bx plus c. And remember, each one of these coordinates represents an x and a y. So I'm going to have 3 separate equations, one for each coordinate, where I'm going to let f of x equal y. So for the first one, f of x is 32. And then for every x here, I'm going to plug in -2. So this is a times -2 squared plus b times -2 plus c. Okay. For the second point, and actually I'm going to rewrite that. Let's rewrite that now. So it's 32 is equal to 4a, right? -2 squared is 4, minus 2b plus c. From the second coordinate, y is 5. X is 1, so that's nice because that's easy to work with. 1 squared is 1, so this is just a. B times 1 is b plus c. So it's nice when you get a value like that. For the third coordinate, y is 17. Okay, for every x, again I'm plugging into here. I'm going to plug in 3. So 3 squared is 9, so that becomes 9a. 3 times b is 3b plus c. So here's my 3 equations. So now I have a system with 3 different variables. So let me show you what we're going to do here. We're going to work with 2 at a time. I'm going to start with the first and second equation. And what I want to do is eliminate one variable. And I think the easiest one here to eliminate will be b. Okay, so I'm going to continue over here. I'm going to rewrite this equation. 32 equals 4a minus 2b plus c. I'm going to take this second equation and I'm going to multiply it by 2. Okay, so that the b's will drop out. So remember, everything gets multiplied by 2 starting with the 5. So that becomes 10, and then I'll have 2a plus 2b plus 2c. Okay, so the b's drop out, and then I add everything. So 42 is equal to 6a plus 3c. Okay, next I'm going to work with the second and third equation. So let me rewrite the original here. It's going to get a little messy up there. So that was 5 was equal to a plus b plus c. That was from the second coordinate, 1, 5. So I'm going to work with these 2 equations. And again, I'm going to eliminate b. So I'm going to rewrite the first one. 17 is equal to, I have 9a plus 3b plus c. And I'm going to multiply this equation by -3. So again, every term gets multiplied by the -3. So that's -15 minus 3a minus 3b minus 3c. The b's drop out, and then when we add these up, we're going to get 2, 6a, and minus 2c. Okay, now I have two equations with just two variables, a and c. So I'm going to work with these two to eliminate a variable. And as you can see, I have the same coefficients for a, so I'm going to eliminate a. So I'm going to leave this equation here. I'm going to bring this one over, and I'm going to multiply everything by -1. So I have 6 and -6. So that's -42, -6a, and minus 3c. So when I combine these, I get -40. The a's drop out, and I get minus 5c. Dividing gives me c equal to 8. There's my first unknown. Okay, now I can go back and plug this into any equation to solve for a. So let's see. I guess I'll just go back to this one. So 42 is equal to 6a plus 3 times c, which I now know is 8. Okay, so I'm plugging into this equation. So that's 24. Subtracting 24, that leaves me with 18 is equal to 6a, so a is equal to 3. Okay, now I have two of my variables. So again, I can go to any equation. I'm going to go back to this one to solve for b. Okay, so if I'm plugging into this one, I know a is 3. I know c is 8. I get 5 is equal to 11 plus b. Subtracting 11 gives me -6. So now I have all three variables. I can go back to my original standard form. I'll write it one more time. ax squared plus bx plus c. Oops. And I can plug in the three unknowns. So I get f of x is equal to a is 3, so it's 3x squared. B is -6, so it's -6x. And c is 8, so plus 8. And there is the standard form of the parabola that would go through these 3 points. Quite a bit of work here, right? So you need to be very organized with your work. Be very careful when you're distributing. Okay, a lot of chance for error here. So I want you to try another one. On the next page, here's an additional example 4. Go ahead and give this one a try. Stop the video. Set it up. If you need to refer back to that example, go back and take a look at it and see if you can come up with the values for A, B, and C. When you're done, come back and we'll compare solutions. Okay, let's see how you did. Hopefully you came up with this quadratic here, -x squared plus 2x minus 3. So here's my original setup. The first equation, this is for the point 2, -3. The second equation is from the point 3, -6. And the third one is from the last point, -1, -6. So these were my three equations that I started with. Again, I started with these two equations to eliminate b, just like we did last time. So I multiplied this equation by 2, and I ended up with this equation, 6a plus 3c equals -15. Then I went back and again used the third equation, multiplying by 3, along with the second equation. Okay, so here's that second equation here. I just recopied it. I put the constants on the right this time. Excuse me. And I multiplied the last equation by 3. That gives me this equation here. Add them up, the b's drop out, and I end up with this equation, 12a minus 6c equals 30. Or I'm sorry, 12a plus 4c equals negative 24. So now I have these two equations in terms of a and c. I took this one and multiplied by negative 2. That gives me the equation in green. Negative 12a minus 6c equals 30. When I add these together, the a's will drop out, and I can solve for c, and I get negative 3. I used this equation, so you can use any equation that involves c and a. So I could have used this one as well. It doesn't matter. I chose to use this one, so I plugged negative 3 in for c and solved for a, and I got negative 1. Now I have c and a, so I went back to this most basic equation because now I need one that has a, b, and c in it. I plugged in for a and c and solved for b and got negative 2. So here's the final answer where a is negative 1, b is 2, and c is negative 3. We'll do some more of these in next class. Okay, example 5. So I hope that you watched the video, the YouTube video about quadratic regression. If you didn't, you should pause this video now and watch that one, because I wanted you to watch that first so you can see how to use Desmos. Okay? Because I'm going to show you this example on Desmos. It's best if you've already seen that Desmos video. So these are all of the horizontal distances and heights of one of Esteban's discus throws. The points show the horizontal distance the disc traveled in meters and the height of the discus in meters. Okay, so I'm going to show you the video.
Esteban is training for the discus throw. His coach recorded the horizontal distance and height of one of Esteban's discus throws. The points show the horizontal distance the discus traveled in meters and the height of the discus in meters. Use quadratic regression to predict the height of the discus when it has traveled 15 meters from Esteban. The data shows the discus only rising, but when the discus starts to fall to the ground, it will make a shape that looks like a parabola. The model should be a quadratic function. You can use graphing technology to perform quadratic regression with the data. Enter the coordinates of all of the points into the table.
So this is how to do it on the calculator, if you have a graphing calculator.
Then find the regression features in the calculator's menu. Since a quadratic model is needed, choose quadratic regression. You can write the regression model using the values from the calculator. You take a, b, and c and put them in a quadratic equation. X in your model stands for the horizontal distance of the discus from Esteban. Since you want to predict the height where the horizontal distance is 15 meters, substitute 15 for the horizontal distance in the model. Then simplify. Based on this model, when the discus is 15 meters away from Esteban, it will be at a height of approximately 10.5 meters.
Okay, so there's another example of how you can use quadratic regression to find the standard form of the equation that represents all of those heights. So this is actually really nice because these tools do all the work for us. All we have to do is enter the data. So let me show you on Desmos. Here is the table that I set up with all of those values. Okay, so you set up the table first, just like you saw in the video, the YouTube video. Then you enter this equation. This symbol is over top of, it's to the left of the number 1 on your keyboard. You hit Shift and that button, okay, and you will get this symbol. So don't use an equal sign here or it won't work. It must be this symbol, which is our symbol for similarity in geometry, if you remember from geometry. So here's my values of A, B, and C, just like you saw from the previous video and the example. I can plug those in to the function and then calculate any height that I wish. Okay. Okay, so we'll go over more quadratic regression in class as well. So the concept summary, there's our standard form. Here's an example. We have a function, a quadratic function. Remember the vertex, we find the vertex by doing negative b over 2a. Okay, then we can substitute h for x and solve for y to get the y coordinate of the vertex. So we calculate that negative b over 2a, plug it in, we get our y value, which in this case makes the vertex negative 2, 9. The axis of symmetry, remember that's a line, so it's not just a number, it's x equal to negative b over 2a. So in this case, x equal to negative 2. The y-intercept, remember we always get that by letting x equal 0, which ends up being the constant of your function. So in this case, it's 0, 1. And then we can use those points to sketch the graph. We can plot the vertex, the y-intercept, and then use symmetry to get another point. So that concludes our lesson for 2-2. I hope you enjoyed it. Have a good day.